Hello everybody. This lesson is about exponential functions. First, let's go over the definition. An exponential function is a function of the form y equals a times b raised to the power x. It grows by multiplication. And lastly, when graphed, it will be a curve. Let's look at the equation more closely. Y equals a times b raised to the power x. This a, the coefficient, is the y-intercept. We have a b, and the b is what's known as the multiplier. Okay? Then a quick note here, this x, the x is an exponent. Of b, so it's b to the power x, not b times x. A couple more things here. When the multiplier is bigger than 1, so when the multiplier is bigger than 1, in other words, b, the multiplier, greater than 1, the function increases. That should make sense, right? Because if you multiply a number by something bigger than 1, the number is going to get bigger. And so when we graph our exponential function, it will be increasing, and it'll look something like this. Okay. Next, we should note that when the multiplier is smaller than 1, but it can't be negative. We're not going to allow that. So when the multiplier is smaller than 1, but greater than 0, and the way we can write that with inequalities is b, our multiplier, is less than 1, but greater than 0. So when that is the case, the function decreases. So when the multiplier is smaller than 1, but greater than 0, b is less than 1, greater than 0, the function decreases. And hopefully that should make sense too, because when you multiply by a number that's smaller than 1, the number is going to shrink. When you multiply by a decimal, it gets smaller. And so our function will look something like this. From left to right, it'll be going down. Okay, last thing to note is exponential functions are never negatives. And what I mean by that is, if you look at these pictures above that I drew, just a rough sketch, the exponential functions never cross over the x-axis. They're never negatives. They can have negative x values, but they will never have negative y values. They're never going to cross under into the negative y values. And this is true in Math 1. You'll learn in Math 3. Sometimes they do have negative y values. But for now, just think about it like this. Exponential functions will never have negative y values. I'll call them never negatives. We're going to do 3 examples. We'll do the first 2 together, and then the third one you'll do on your own. Example number 1. Graph y equals 3 times 2 raised to the power x. So the first thing we note here is this number in front, 3, is our y-intercept. And the second number, the base, the number that's raised to the power x, is our multiplier, which is 2. And we'll note here that b is greater than 1. The multiplier is greater than 1, right? It's 2. So the function will be increasing. Okay, in order to graph these, you do need to make a table. So let's make an XY table. And we can choose negative x values. That's fine, but remember, these are never negatives, so there won't be any negative y values. Okay, so the y-intercept is 3. So 0, 3 is a point. Let's make that red. We also know the multiplier is 2. So to get to the next number, all I need to do is times by 2. So when x is 1, 3 times 2, that makes 6. And when x is 2, I can multiply by 2 again to get 12. Alright, now working backwards, I don't know what this is, but I know that this number times 2 is 3. So another way to do it is 3 divided by 2, and 3 divided by 2 is 1.5. Same for this one. I know that whatever this is times 2 is 1.5, so to go backwards, I can take 1.5 and divide by 2, and that gives me 0.75. Okay, let's graph. Alright, so our first point, 0, 3. That's our starting value, or y-intercept. We got that right from the equation. And then to get to the next point, we go over here to 1 and 1, 6. You can kind of see the growth, right? 3 to 6, that's times by 2. And then for the next point, if we go over to 2, and then go up 12, there's our next point. And you can kind of see the growth there. 3 times 2 is 6, 6 times 2 is 12. So you can guess that when we go to 3, I would have to put the next point at 24, which I won't do because I don't have enough room. Okay, and negative 1, 1.5, negative 2, 0.75. These are my points, and if I kept going, I'd keep getting closer and closer to the x-axis, right? Really, really close. But since this is a never negative, it's not going to cross the x-axis. And let's see why that is real quick. This is just for fun. Let's say we plug in negative 10, right? We want to find negative 10. So y equals 3 times 2 raised to the power negative 10. Whatever this output's is going to be our y value. Now remember that when you have a negative exponent, what you do is you cross the line and change the sign. You keep the numbers, but you flip it, and then the exponent becomes positive. Cross the line, change the sign. So simplifying this, a whole number times a fraction, you put the 3 over 1, and then you multiply straight across. 3 times 1 is 3, divided by 1 times 2 to the power 10 is still 2 to the power 10. And then you use a calculator to do the rest. Alright, here's my calculations. You can see I did 3 divided by 2 to the power 10. And it came out with a really, really small number, 0.0029. So really, really small, but not negative. And because of this negative flipping of the fraction, that's why these things never go under the x-axis. That's why these are never negatives. Alright, example 2. I said we were going to do 3 total, but I lied. I think this has gone on long enough. Let's just do this last one. So I'm going to need your help with this one. And the first thing I need your help with is, what is the y-intercept? Based on this equation, graph y equals 4 times 1/2 raised to the power x. The y-intercept is? You should have said 4. It's the number in front. It's the coefficient. All right, and then based on this equation, what is the multiplier? You should have said the multiplier is 1/2. Okay, and then I want you to make a prediction. Based on the multiplier, will this function be increasing or decreasing? You should have said decreasing. Makes sense, right? If you multiply a number by 1/2, it's going to shrink. We'll just make a note here. The function will be decreasing because b, our multiplier, which is the letter b, is less than 1. All right, let's make a table. And in my table, I'm going to choose 5 x values, -2, -1, 0, 1, 2. These are never negatives, so the y values will always be positive, but it is okay to have negative x values. All right, now I'm going to fill in 4, because that's my y-intercept, 0, 4. What would x be? Or I'm sorry, what would y be when x is 1? So what do I put right here? I should put 2, right? The multiplier is 1/2, and 4 times 1/2 is 2. How about down here? What comes next? When x is 2, what is y? Y is 1, right? Because again, you multiply by 1/2, causing it to decrease. How about when x is -1? What would y be when x is -1? That's going to be 8, right? Because 8 times 1/2 is 4. Another way to think about it is we're dividing by 2 kind of to go forward. So to go backwards, you just multiply by 2, and 4 times 2 is 8. One more. How about when x is -2, what is y? 16, right? Again, working backwards, 16 times 1/2 is 8. You can also think about it like 8 times 2 makes 16. Last thing to do is graph this thing. So what I'd like you to do is just pause the video, try it on your own first, and then unpause the video when you are done. All right, let's see how you did. 0, 4 is the y-intercept. 1, 2, 2, 1. So go right 2, up 1. And then when x is -1, y is 8. And when x is -2, y is 16. You're going to connect these with a smooth, continuous curve. And it should get really, really close to the x-axis, but it should never cross the x-axis. Just like that. So I see a lot of students make their graphs like this. Just a tiny little piece. But don't just make a tiny little piece graph. Keep it going, keep the trend going, draw an arrow in both directions. Avoid that. Thanks, everybody.